So today I'm going to try to give you a bit more of an optimistic take than yesterday. So yesterday I was the realist, today I'm going to be the idealist of sorts. And you may be wondering, why finance? Right, so there's these people fighting climate change, building better nitrates for agriculture and better yield, and then here we come, the banks, to make more money. But there may be an angle there. The second industry that hires more physicists after academia has been finance. So if you look at any financial institution, it's full of physicists and mathematicians, usually known as quants, not from quantum, but from quantitative analysis. And there is some relationship there in the sense that at the end of the day, the word quantum comes from quanta, comes from discrete amounts of things. That's how the nature actually happens to be, right? Either discrete amounts of photons or energy or money. So at the end of the day, banks are the best in the world at counting your money. And in a way, that's a nice way for us to say, if there is anything for us to use this technology, maybe we have to explore it. Whether those use cases have real long-term applications or not, maybe we can learn from it. And our angle in there is a little bit on that quantitative stuff, meaning what is the business of banks and insurance companies? We take the money from your payrolls, from your investments, and we put it somewhere else with the hopes of making a multiple on that money. On insurance companies is something similar, right? They take your premiums and invest that money in portfolios. And Thierry was mentioning portfolio optimization as well. So we put that money in the best portfolio possible, so we get a multiple and make money out of it. Pretty old business, many hundreds of years old, that has been running well with some, hiccups along the way, like things like 2008, for example. What happens when people get greedy? What happens when we see things like FTX recently? And how do we put some control in there? So as an industry, it's a heavily regulated one, as you can imagine, on how do we take care, how banks, insurance companies, and the likes take care of people's money, and how that money flows and makes the economy survive or thrive, depending on how you want to use it. Now, what's the quantum part of it? At the end of the day, most of the problems that we have in pretty much all the industries can be divided into three that Ignacio mentioned before. Either simulation problems, machine learning-based problems, and optimization problems. So let me start from the last one, optimization. You have hundreds, thousands, millions of combinations. Which one do you choose? Right, if I give you $15 to choose the best plates to choose in a restaurant, well, not 15, but 50, and you have 30 options in the menu, your brain will have to quickly work that equation and then say, yeah, I'm going to get this first, this main, this dessert, like yesterday's cheesecake, that was fantastic. But if you have tens of thousands of options, your problem gets bigger and bigger and bigger. Now, maybe a simpler example is a Sudoku. Right? If I give you a Sudoku, there are billions or trillions of combinations of that problem. Yet, if I give you one solution, you will quickly know whether that solution is correct or not, or better than any other option. So that's the business of banks on a daily basis, right? Finding what is the best way to allocate and deploy that money. And as an industry, we've become really, really good at doing that. And we've used a lot of extensive methods. So one of the first questions we have to ask ourselves is, can we do better than our classical solutions? It's not just that quantum computers can solve this problem, it's whether they can solve it better. And I will get into the better in a minute, because better doesn't need to be, that's the optimistic side of things, doesn't need to be quadratically faster or exponentially faster. Maybe it's just a business advantage that we can find as we move forward. The second case is simulation. And I don't know if many of you know about the concept of Monte Carlo simulation. How many know about Monte Carlos? Oh, perfect. So I don't have to explain the marbles going into the floor and the bucket and all that. It is a very rudimentary way of analyzing risk, if you think about it. like, hey, let's evaluate all the different options and calculate as many as we can with the computational capabilities that we have, so we forecast the best risk possible. If there is an algorithm that promises any type of a speed up or accuracy on running our Monte Carlos, which is the case, then we have to take advantage of it. Now, there's a lot of research on that, specifically taking the quantum amplitude estimation path, and there are many, many limitations as well on what we can do. But there's a lot of research that we still need to do together with academia. What do you mean by together? In many cases, what we see from the literature is that the algorithms are not really matched with what the industry does. They provide a nice representation of how we could solve this problem, but then the day-to-day of the business side and the banks or insurance companies is a little bit different. And even if you take it to the innovation teams in the corporates, where sometimes you find quantum engineers or quantum algorithm designers, they are still detached from the business, to the point of not even knowing what the other side of the company are doing. So I can give you 2 points of 2 data points. We ran a survey like 3 months ago to about 450 banks in the world. 52% replied that their number one concern, their most important thing, the only thing they care about is their cloud migration. So when you go and tell them about quantum computing, they say, well, hold on, I still need to secure my systems the classical way. But then from the rest, they said, I want to work in quantum. I've heard about this. I read the news about this cracking the internet thing and all those headlines that we've been talking about for a while. I want to work on those use cases. Now, from all those who say that, about 150 people, 30 of them had active quantum computing groups, like quantum and physicists, people in their banks. They were not aware of it. The business side didn't know about it. So there's a clear disconnect even within corporates on how to do that. And then from those who knew, the use cases that they chose were completely irrelevant to the institution. Maybe they chose that use case because it was a low-hanging fruit, because the algorithm was there, or maybe because they didn't ask the business side. But when we talk, for example, about portfolio optimization, the reality is that on the business side, most institutions make those calculations once a month or once a quarter. So when you speak with the head of asset management, they say, that's great that you can do this in seconds that usually takes 8 hours or 2 days. But you know, I run it only once per quarter. What's the benefit of that? And that was my point yesterday on the so what. Now, there are other cases where then they raise their eyebrow and they say, that's interesting. And that's my third point in terms of machine learning. And I'm really grateful that Virag mentioned that as the third potential use case. Now, when you bring in quantum machine learning, then suddenly you have a Damocles sword of sorts. When you talk about classical machine learning, something magical happens. And it's like, for some reason, problem complexity, computer complexity, doesn't apply as good as in other type of algorithms. Right? If we take from the NP-hard perspective, neural networks should not work. Yet they do, in some cases. And when you apply quantum machine learning, there is absolutely no proof that we can do better. But in some cases, we can see better accuracy on some of the reports or some of the experiments. Things that we're trying to do in the industry. Fraud detection. So we put a lot of transactions from consumers, credit card, and we try to evaluate which ones are potential fraud transactions. Weather modeling, not prediction, but modeling. Can we use convolutional networks to analyze satellite images and predict potential hurricanes or tornadoes? We've seen in some specific cases, and I cannot claim that this is a fact or something that we cannot even publish, but in some cases we've seen potential good improvements on the accuracy, up to 15–20%. Is that only on that data set? Is that only on that case? I don't know, but what I know is that it is worth to explore. Because in the meantime, those other cases on the simulation side, we know that they will take much more time to get there. So to wrap up, on those three cases, at the end of the day, those are the offensive mechanisms. What do we do as financial institutions to improve our products, to be more efficient, to keep this edge on the best usage of our money? Then there are the defensive mechanisms, which are the cybersecurity elements. How do we implement post-quantum cryptography into our system, and how do we partner with that? I think one of the points that I mentioned yesterday is that every single company, especially financial institutions, should have a very clear quantum plan, an AI plan for that matter. And with that, moving forward into being on top of the situation, we don't care so much when quantum advantage happens. What matters is that whenever that happens, we are right there. And then to finish, what is quantum advantage? If you take it from the pure scientific perspective, is can we prove mathematically or experimentally that we have a polynomial speedup or an exponential speedup? But from the business side, there are other types of advantages, whether it is improved accuracy on our ensemble models between classical and quantum machine learning, or maybe because I do things with an Excel spreadsheet now in a very inaccurate way, and I leapfrog all the way to other systems. Or we were mentioning before, maybe I'm using less energy. Yeah, yesterday was the point. Maybe I'm improving my ESG scores. So all those elements are also relevant for not only for finance, but other industries. And we have to look beyond the polynomial speedup. That's it.